Okay, good afternoon, class. I'm going to try to finish this PowerPoint for you here. Let's go to presentation mode real quick, maybe. There we go. Okay, so we're going to go through five little examples on sizing control valves. The first three are two-way modulating valves, and the last two are three-way mixing valve type applications. Let's see, let's check the notes here on the page. Under 1, 2, 3, the two-way modulating valves. Valves are selected to a minimum pressure drop of 10 feet. That's to have some authority, they call it, or some controllability, so that when that valve starts to modulate shut, it immediately affects the flow. And so a minimum of 10, not to exceed 20 feet, because of we don't want excessive velocity. Our wire drawing has to do with the high velocities cutting. You get it pretty much closed, and what flow goes through is high velocity, and it can erode the valve seat. That's called wire drawing. And then on the three-way valves, the valve size for 3 times or more of the coil pressure drop if possible, again to a maximum of 20-foot pressure drop. So we'll be referring back to those, or we'll be using those selection criteria here. Okay, so here are the control valves that we will be selecting from in this example. You see we've got from 3/4 inch all the way up to 4-inch valves. And then each valve can come with 3 different orifice sizes. And so we're not given the dimensions on the orifice, but we are given the CV rating for the valve, which is really what you need anyway. So that's, let's see, control valves. They don't have to be line sized. Now, in this example, in the spreadsheet you all did, there was a geometry factor that you calculated and put into your spreadsheet. Bell and Gossett glosses over that geometry factor in these slides. It is proper to include that, or I guess they would just say that, well, any geometry factor is included in the CV rating, but that's obviously not the case. But at any rate, and then this last note, a maximum circuit pressure drop variation of 25% with all valves wide open should be a design objective. And we'll talk more about that when we go through the particular examples here. Okay, so let's move on to example 1. And you see it's pretty simple. We've got a system pump kind of in the center with a coil on the left and right, and the flow is coming vertically out of that pump, and you can see by the flow paths in the 2 loops. We have control valves that we're going to size, and everything else, balancing valves and all that, even though they're not shown, would be included in these circuit drops that are given. So we see the circuit on the left is a requirement of 50 gallons per minute and has 18 feet of head, and that's everything in that flow circuit all the way through the pump, all the way around on that circuit, except the control valve. And likewise on circuit 2, we're needing 30 GPM, the coil on the right, and that circuit, excluding the control valve, has 12 feet. And there's numerous other components in there. They're just, for simplicity, they're not showing them. Okay, so here's how we go about this. The circuit with the highest pressure drop, number 1, is valve size first, in order that circuit number 2 valve can be selected to balance the circuits. So when we're finished, we want to have the same pressure drop around each one of these circuits. And it may require using a balancing valve to add some drop to one of the circuits to get it up, to get it to match the other circuit. Okay, so the second bullet here, the valve for circuit number 2 is sized for a 10-foot, 10 feet pressure drop at 50 GPM, requiring a CV of 24. Now, I want you to get out your calculator And remember, the equation we're using is Q is equal to CV times the square root of the pressure drop in PSI divided by specific gravity. Well, in all of this, we're assuming specific gravity is 1, so we're not worrying about that. Now, if you're doing a hot water system, you would need to include the specific gravity in the calculation. But for a chill water, condenser water system, this would be, say, for a chill water system, because we're not making the specific gravity connection, I would assume. And so we're going to drop that out. So in order to check that 24, let's do that. So first of all, you want to take the 10 feet now, and that's, you have to convert that to PSI. So divide by 2.3. Now, normally we use 2.31, but I think the numbers match these examples. I think they just rounded it to 2.3. So I take 10 divided by 2.3, and that's 4.37. And then I want to take the square root of that, and that's 2.085. So I'm going to store that away, and then I'm going to take my 50 GPM and divide by that 2.085, and I get basically 24. So that's my CV for that circuit.